Welcome. I'm glad if you are following my videos on set theory. One thing you should know is that set theory may seem to be not so much of a complicated stuff, but this is the backbone of mathematics. Once you understand set theory, there should be no topic that should be of challenge to you. So make sure you follow it vividly, understand each and every concept that we talk about. And remember, this mathematics or the first year mathematics is not a mathematics that you go straight into solving complicated equations here and there. You first need to understand the definition of each particular concept you are talking about. So all these definitions that we've discussed so far, you should know these definitions by heart. And like that, trust me, you won't have any challenge in understanding or solving the first year mathematics. So we continue with the definitions on set theory. Remember, I'm your host, Upe Kolosa. Remember to like and subscribe to the channel for more videos. So we've talked about so many definitions of a set. We've talked about subsets. We've talked about disjoint sets. So many sets. And we've talked about the universal set. That this is a set that contains any other set that is under discussion. So now, today let's look at the Venn diagram. What is a Venn diagram? By the word itself, diagram, this shows that it is just a pictorial representation of a set. So any diagram that contains sets in it, that is called a Venn diagram. A pictorial representation of any particular set. And this is shown in a rectangular drawing. So as we can see, we have a drawing here. The outer set, which is a rectangle. This is now what defines the universal set. Remember, we defined the universal set to be the set that contains any other set that is under discussion. And this can be denoted by the U, as we can see from here. If we are not using the symbol U, we can use the capital E to represent the universal set. Remember, any other set is denoted by the capital letter. So under this Venn diagram, or under this universal set, we are having three sets. One is set A, the other one is set B, the other one is set C. So maybe let's go step by step to represent this Venn diagram. So what we have is this. So whenever you are representing your sets under a Venn diagram, you first begin by representing the universal set, because any other set that you are going to talk about is going to be under this set. So let's suppose we are talking about set A. Our set A has the elements 1, 2, and 3. Set A has the elements 1, 2, and 3. And if we want to represent this set A under the Venn diagram, we first begin with the universal set. Then under the universal set, that is where we are going to have this set A in capital letter. Then the elements 1, 2, 3 are going to be inside set A there. If we have two sets, we also have set B, which has the elements 4, 5, and 6. Remember, definition of a disjoint set. We said there has to be an element X in A, and that element is not supposed to be in B. Then the two sets are disjoint. That implies that A is not the subset of the other. So how do we represent this in a Venn diagram? So again, you begin by showing the universal set denoted by either a U or E. So we are talking about two sets here, 1 and 2. And these two sets are disjoint, meaning there is no element that is appearing in both sets. So what we are going to have is the set A and set B, because we don't have any elements that are appearing. So the two sets are disjoint, they are independent of the other. So here you are going to have the elements 1, 2, 3. Here you're going to have the elements 4, 5, and 6. So now, what if we happen to have our set C with the elements? We can have 6, 7, and 8. How do we present these three sets under the universal set? So, same thing, begin by noting the universal set. So, you have set A, you have set B, but now here, take note that in set B we have the element 6, and in set C we have the element 6. So meaning this 6 is appearing in both set B and set C, meaning it's going to be an intersection. So if this is your B, there's going to be somewhere a set C here, which is having the element 6. Then 7, 8 only belong to set C. Here we have the elements 4 and 5. Here we have the elements 1, 2, and 3. This is your universal set. So this is how a Venn diagram should look like. The power set. What is a power set? Remember, what we started with was denoting. On the previous session, we showed how we can find the number of elements or the number of subsets in a particular set. So if we say that let A be a set, to determine the number of subsets that are going to be in set A, we are going to determine this number of elements by 2 to the power n. So if set A, or if our n is equal to 3, that implies that we are going to have 8 subsets. Remember, in the previous video, I was using set B to denote these 8 subsets. But the whole of that 8 subsets is what is called the power set, and it is denoted by the power set of A. So this is basically a set containing all the subsets of A. That is a power set. So we can look at this example. If A is equal to ABC, then the power set is going to be the whole of this set. So remember, a power set is the set containing all the subset of this set. So here we first begin by the empty set. We've already determined why the empty set is the subset of each set, of every set. Then after that we also have the full set A. It is the subset of the set itself. Then we're going to have the smaller sets inside. And since we are having 3 elements in here, we are going to have 8 subsets. Now, the group of all these 8 subsets is what is called the power set. Okay? So note that if A is the set with n elements, then the power set of A is the set with 2 to the power n elements. This is what we've talked about already. Perhaps we can look at this example. So let's set A. Let's call it B now. If we have our B to be 1, 2, 3, and 4. what is the power set of B. So what we are looking for is the power set of B. And we are saying the power set of B is the set that contains all the subsets of set B. So now, how many subsets are we going to have? And we say the number of subsets is going to be determined by 2 to the power n. And in this case, our n is equal to 4. So we're going to have 2 times 2 by 2 by 2, which is giving us 16. So in this power set, we should expect 16 elements, starting with the empty set, which is the subset of every set. Then after that, we can have the set itself. A set is a subset of itself. Then we can have smaller sets, which we are going to obtain by just listing each particular element to be the set on its own. So here we can have a 1, the other set 2, until we list all the elements that we have in B. Comma, due to lack of enough space, I'll start from here. So we are going to say the next will be a combination of these. This is 4. The combination of 2 elements. So the next set can be a 1 and a 2. The next one, a 1 and a 3. The next one, a 1 and a 4. So we are done with 2. And remember, the elements need to be distinct. So from there, we can go to the combination of 3 elements. So we can have 1, 2, 3. We can have 1, 2, 4. Then another set can be 1, 3, 4. Like that. So how many elements so far? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are some more elements missing. Which element is that? So we can go to the combination of 2 and 3, 2 and 4. 2, 3. We also have 2, 4. There we can also have 3, 4. Remember, you don't need to repeat the same combination of elements. How many so far? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There is one more missing. Which one is that? We have 1, 4. We have 2, 3, 2, 4. We have then 3, 4. We have let's identify the element that is missing. 1, 2, 4. We have 1, 2, 3. We have 2, 3, 4. Do we have 2, 3, 4? We don't have. So that is the set that is missing. 2, 3, and 4. So all these elements, starting from the empty set all the way to 2, 3, 4. This group is what is called the power set of set B. Thank you so much. Watch out for the next video. By liking and subscribing, you'll be able to be notified whenever a new video has been posted. Keep on practicing. Math is easy.